Hello everyone. Last section we talked about what eutrophication. Eutrophication. What is obvious in eutrophication is growth of algae, right? We are seeing mainly greenish lake. So many factors led to algae growth. One was phosphate, right? Phosphate, CO4. And the phosphate or nitrogen led to growth of algae. Then when we have photosynthesis of algae, we have what? Chlorophyll A, chlorophyll B, carotenoid. But we are focusing, for example, chlorophyll A. We can detect chlorophyll A always in the lab by one main mechanism, either UVBs or spectrophotometer. Both of them the same mechanism. At different wavelengths, we will detect chlorophyll A, right? So if we assume that we are in the lab, so we are in the lab, we have the algae growth. So this is our algae culture. We take the sample, we dilute it. So first of all, we have 0 with no algae, it's a blank. Then we have 5, 10, 30, 50, 80, 180. These are milligram per liter of chlorophyll A, right? The unit is milligram per liter. You have to calculate, you take a sample, you calculate, you will make different concentration, right? Almost like 6 or 7 concentrations. So 7 concentration. So these are, each concentration have density of algae cells, right? If it's assuming this is a chloroboncaris, they are single cells. So, and each number from 0, that's blank, all the way 180, they will give us a trend of density and concentration. So what about if we take a picture of them, right? Why can we translate the density of each algae to pixel? Of course we can do that, right? So we're gonna take a picture of each one. It doesn't matter what camera you use. So we are assuming that for blank portion you have nothing, then you have 5 for few cells, then you have 30 milligram per liter, 5 milligram per liter, and 0 milligram per liter. The 30 would have more, and imagine this is 180 milligram per liter, so it would be more dense, right? It's more dense. More cell we have, then if we take a picture, it would have more pixel. So we want to make a calibration curve. This calibration curve on y-axis, we will have a pixel, right? Pixel. And on x-axis, we will have concentration. Concentration milligram per liter. This is 180, 180, 130, 0, and here we have pixel. So if we make a calibration curve, the curve would be like this, almost, and one linear relationship. We will have a linear relationship, like y is equal ax plus c, right? So we want to implement this one. So just assume the same lake last time we talked about, it was Lakeview. It was on the border of Louisiana and Texas. Lakeview. The city has came up with the solution to make a pond to solve the problem of eutrophication. Lakeview. However, you go to the field, you take a sample of the water, right? You have the sample. This is unknown concentration, right? Unknown. At least you take 3 samples, right? At least you take 3 samples, unknown concentration. But you have already measured in your lab the density of the cells you will get with all the optical density, and you also calculated the chlorophyll A. So we want to do the code, and we're going to do image processing. Then if you take the sample from the lake, you will take a picture of them and you give a picture to your computer. Without taking to the lab, you can just get the result based on what you had already in the lab, right? You don't need to do a lot of extraction, analysis, whatever. You can just estimate what is the concentration in the lake, right? So we just need to take a picture. I will show you how in Colab, in a basic way, a simple way, we can process this image, right? The unknown image, and come up with concentration. If this is calibration curve, what can be this concentration? Maybe it's 150, 130 milligram per liter or whatever. This is very simple way and basic thing. So we need to take a picture from all at least 5 to 7 of our sample from 0 to 180. I have uploaded the images in a folder in Blackboard. You can take those images, and I explain to you how you can process them and get the calibration curve. Hello everyone, I hope you can hear me. So as I discussed in the previous session, eutrophication, we go into Google Colab. We practice in last 2 sessions Google Colab. So here we click on a folder, we upload our, just wait a few minutes, this window will pop up. Now you upload your images. No, let me see. No. There's picture 1, calibration images. Oh, I upload it here. Okay. Open. So I uploaded 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think I put for you 7 images, but here's 6 images for me. From 0 concentration, this is blank, 0 milligram per liter, 10, 20, 40, 80, 60. So let's write here. Write a calibration code for the, it's not AI generated, generate with AI. Write a calibration code for the concentration of Algae versus the pixel. Let's see what it will generate. Okay, now you have 3 options: accept, auto, and run step by step, and cancel. It's up to you that you can go run step by step or accept and auto run. I click on accept and auto run and see what it will give us. So you should be a little bit patient. It will do all the job for you. Loading process, so it's creating the code and it will run for you. So the Gemini is working for you now. Let's see. It takes some time. It's performing the calibration now. You can do step by step, or you can let the system to do it for you. Visualization calibration. So it has calibrated for you. Different pixel, different concentration, right? This is algae concentration versus pixel. As the concentration is getting higher, the average pixel should go higher. Why is giving negative? This is 150. Concentration is 150. The pixel should be higher, not lower. Let's see what was the problem. Okay, let's redo it. Because the slope is fine, but the pixel intensity does not make sense. We should have here higher density at 150 milligram per liter. See. I'm writing redo the calibration curve as the higher concentration should have higher pixel intensity. You are right, the current calibration shows the inverse relationship. A higher concentration of algae should generally lead to lower average pixel.
So a higher concentration of algae should generally lead to a lower average pixel intensity, darker image. Let's recalculate the pixel data and to reflect the change in the intensity relative to the image zero concentration. Okay, so it was actually right. Based on explanation, as if we go darker, the pixel intensity would be less. So let's, now we have two unknown, right? We have two unknown. Let's see if the unknown I put for you on the blackboard. We have unknown images. These are three unknown for concentrations of unknown. Let's download one of them. Download original image. Okay, I will copy this into this Algae unknown. Let's go back to Google Colab. Here we are uploading the Algae unknown, this one, right? Then again generate. Let's copy the path here. You see in three bars here, three dots, you click. I always copy paste. This is the easiest way. Generate with AI. Estimate the concentration of algae in unknown sample. Okay. So again, you have two main options, accept and run. And accept, I just go easy way. I say accept and run. So let's see what it will estimate for us. Based on that calibration curve, estimated algae concentration for unknown sample is 828.49 milligram per liter. Now you have three algae sample, they are unknown. We took sample, for example, from the lake. You can calculate their concentration. Very easy. And you can use this technique for different things. For example, Somaya is working with carbon quantum dot, and she generated a lot of different images with UV. So it's the same thing. If you have a concentration, if you have more images, your calibration curve would be more accurate. It's better like you have many more data than this little limited data set. So then I hope you learned something really good and you can apply in different research. Let's stop it here and you can practice it now.